Hey, Shishir, will it going?
Yeah. Yeah, sounds good.
Hey, Shishir, will it going?
Yeah. Yeah, sounds good.
So, welcome, Shishir. This is the Information Systems program, and the DAMG students are here. They're all graduate students. You got to give a wave to Shishir. So, Shishir is a PhD student at UC Berkeley, and he works with Joseph Gonzalez, Prabal Datta, and Ian Stoiker, and he's been working with teaching LLMs to use various kinds of systems and on-device ML. He's affiliated with the Sky Computing Lab, which was also called as RISE before, and the Berkeley AI Research Group. So Shishir has done some amazing work. So he has a couple of projects which you can check out, both the papers and his GitHub site, and he's also going to present a couple of links on what you can do on Google Notebooks. And maybe if we have some time later today, we'll do it and try and experiment. But I was particularly interested in some of the work he recently published, combining RAGs and fine-tuning, and talking about the approaches of and also analogies with respect to closed book and open book exams and how you can potentially teach large language models. So I requested Shishir to present his work so that we can also understand like what he's been working on and see if we can incorporate it into some of our projects. Shishir is originally from Bangalore. I got to know that he's also Kannadiga, and he went to Oral College in Bangalore. So I look forward to hearing what his current research interests are and what his work is. And welcome, Shishir. The stage is yours. You can share your screen.
Yeah, and thank you, Shri. Thank you for the introduction. Also, thank you for inviting me to present. I'm pretty excited to be sharing some of what we are
What this work is,
doing
and
today.
welcome to share. The stage is yours. You can share your story.
Uh, okay, and I thought one thing that I'll do to get started with is probably give a brief overview of what we're doing. And then I'll talk to you about two projects, right? One is the Gorilla project. And then we took a lot of ideas from Gorilla that we thought were very relevant for the general purpose, like document question answer kind of setting with the RAFT project. And so I'll talk you through the evolution, how this worked. And then the hope is in between, I'll also show you some demos that you can readily use today. So like Sri mentioned, you can think of using this for your projects or just as just cool toys to play with. So that's the agenda. And in terms of the question answering stuff, if you have any questions, just feel free to speak up.
Hey,
So like
Shishir,
Sri mentioned,
just a
you can think
second.
of using this for your projects or just as just cool toys to play with. So that's the agenda. And in terms of the question answering stuff, if you have any questions, just feel free to speak up. So just a second of using this for your projects or just as just cool thoughts to play. So that's the agenda. And in terms of the question answering stuff, if you have any questions, just feel free to speak up. So just a second of using this for your projects or just as just cool thoughts to play. So that's
Just a second, Shishir. We have some technical difficulty here. We are hearing an echo. Just a second, Shishir. We have some technical difficulty here. We are hearing an echo. Shishir, can you try now?
Check 1, 2, 3. Is it better?
Yes.
Okay. Yeah. So then I think maybe I guess you'll be muted. So if there's anything, chat or we can also do it towards the end. So I've planned this to be mostly about 50 minutes. So we'll have hopefully enough time and we should be able to wrap up soon. Okay. So I'll get started. And just as a high level overview, um, when we tried to like build the Gorilla project, right? So there was a few interesting things that we had to do. One was, well, APIs change very frequently. So how do you keep up to date with the freshest of data? How do you keep your LLMs up to date is something that we had to answer. And so that's the retrieval aware training aspect of it. Now, the other interesting thing that we had to do was also try to see, well, can we actually measure hallucination? And for measuring hallucination, there was no good metric before. So we also had to define a metric that helps you do this. And both of these are actually quite general ideas that we used to train the gorilla model. So we took the retrieval aware training and we generalized it to more natural language beyond API documents. And so we call that the RAFT project. And then the measuring hallucination, since it was so critical, we also used this metric to not just benchmark our models, but also a bunch of different models from open source and closed source providers as well. And so that's the open functions leaderboard. And we also trained an open functions model, and there's a little bit of interesting work on the execution engine. How do you make sure that when these agentic systems are operating in the real world, they may tend to do things, they may tend to screw things up. So can you now provide guarantees so they don't screw up? So that's the idea between the execution engine. So this is, think of this as the evolution of, if you were to think of LLMs interacting with agents, and different tools and services, what needs to be done to get there. And each of this is, in some sense, in our view, a step towards that direction. So with that, let me start off with the Gorilla project. So why did we start the Gorilla project, right? If you think about how people talk to LLMs today, so over here on the left-hand side, I have all the different LLMs, be it ChatGPT, be it Anthropic, or Llama from Meta, etc. Fundamentally, as a user, you are responsible for interacting with the LLMs, right? You call this prompting. You get a response from the LLM, and then it's up to you to decide what you want to do with this, right? So, for example, you prompt the LLM and you get a response. I've shown this as a single shot interaction here, but this could be multi-turn, multiple shots, right? And there's like a whole cottage industry of tools that help you do this, including Llama Index, LangChain, so on and so forth. But fundamentally, you take the response and then you now perform an action on the world and to get some feedback from the world, right? So an example here could be, hey, you want to install CUDA or you want to install a Python package. You ask ChatGPT, how do I do that? So you prompt that over here. ChatGPT tells you, well, here's a set of commands you need to run on your machine. So then you take those commands and you have to go and execute those commands on the machine and then get the response back, which in this case would be the artifact of the Python program being installed, or maybe if you're trying to like do something else, then you get the associated artifacts. Our goal with this project was, can we flip this around, right? So can you have this scenario where the LLM that we train to do this is the Gorilla LLM, and the user prompts the LLM performs actions on the world, validates the response, and then relays that back to the user. So why do we think this is important? Well, this is based on the following observation, right? Humans are good discriminators. Humans are not good generators. So if I give you two recipes for your favorite dish, and I ask you, hey, which one do you think tastes better? You probably can't tell much in terms of how different they turn out. But if I give you the finished product, if I give you two dishes to taste, you can probably taste them and immediately tell me which one you prefer better, right? So that's the high level idea here. Humans are good discriminators, we're not good generators. So with the Gorilla project, our goal was, can we actually replace the human in the middle to actually replace the LLM in the middle? So this is all too abstract. Let me take an example and then tell you how this works, right? So consider the scenario where, we do a bunch of machine learning research. So suppose we say we want, 800 GPU in East US. Now, what Gorilla does is it first identifies that, okay, East US is how you name regions in Azure. So what the user is actually looking for is potentially an Azure view of the world. So once it recognizes that it's Azure that you're interested in, then the LLM starts an instance that has an 800 GPU and then returns the SSH key, which is the artifact in this case, back to the user, right? So this was our idea, and since then the Gorilla project has gone on to include about 20,000 APIs actually, which includes your hyperscalers like Azure, GCP, AWS, payment gateways, Stripe, machine learning APIs, Kubernetes, Salesforce, so on and so forth. So you basically talk to the outside world using your LLM is the idea. Now, before I proceed on some of the interesting scenarios, let me also show you some examples. Okay, what I'm going to do here is I'm going to ask a simple question. So this is, a normal terminal, and I'm going to say, okay, Gorilla, list all my GCP instances, right? And so what you're going to do is you're going to ping the LLM, and the LLM is going to show you a bunch of commands, and then you execute those commands, and then you get back what instances were running in my Google Cloud instance. What I'm trying to show here is that APIs are quite powerful as different modalities. And here's one example where I'm trying to talk to my Google Console as a service using APIs. But you could also think of different ways how you can do that. In this Colab example, what I do is I have an LLM endpoint and I use a chat completion API. This is how you would interact, or you'd prompt OpenAI to give you a response programmatically, right? And I ask the question, I want to translate it from English to Chinese, right? So that's it. Can an LLM do this today? The answer is yes. But we all know there's a high possibility it could hallucinate. So the goal here instead to say, let's actually use API. So here I'm going to use the Helensky NLP Opus MT English to Chinese API. And what the LLM does is gives you an API call, tells you the API provider, gives you some sort of explanation, interpretation as to what's going on. And then you get a code that you can now execute with the API call to generate the translation, right? So here I do the simple Python exec and execute this, and then I get, well, here's the translation of what are the key differences between renewable and non-renewable energy sources, right? So the idea here, as you can see, is APIs come in different modalities. It could be like your bash command line APIs. It could be some of this machine learning APIs from different model hubs, or it could even be some of your hyperscalers, cluster schedulers, etc. And what we're trying to do with Gorilla is like have a common platform where you can interact with all of these APIs using through an LLM. So that's an example. And so by the way, all of these collabs are available. So if you go to the gorilla.cs.berkeley.edu and you click on collab, you see different examples of the notebooks that you can readily use. Okay. Anyway, so coming back. So hopefully I've convinced you that this is real. Oh, and even the CLI, you can install it with pip install Gorilla CLI, and then you can install it and start using it. So yeah, so that's some of the tools that you can use readily. But to do this, right, we had to solve some interesting research questions, and I'll try to surface them today. Now, one of the key ideas that we had to think about with Gorilla is this concept of retrieval-aware training, right? Just to give you some context, making no assumptions, retrieval is where the user asks a prompt, and then you use your favorite retriever setting. This could be like similarity search using BM25, or you could think of more fancier ways to do similarity search. And then you re-rank, you get K documents, like K relevant pieces of text, and then you put that in context along with your prompt and hand it over to the LLM. So this is the setting, right? Now, you need retrievers. Why? Because retrievers are needed for freshness of data, except retrievers can be inaccurate, right? So the key idea between retrieval-aware training is the following. Can you train the model to either use or ignore the retrieved context? So you're basically making the model implicitly determine one bit. Is the set of documents that my retriever gave me relevant, or is it not relevant? So that's the high-level idea. And so how do we do this? Well, there's a few different things you need to do. One of the critical stuff is to introduce correct and incorrect retrieval results during the instruction fine-tuning phase. And And by doing this, what you're doing is you're ensuring that the model is robust to low quality retrieval. So that's one part of it. And I'll talk more about how we extend RAT to general purpose setting in natural language when we come to the RAFT project. But now the other thing that I want to do is talk about the other topic that we had to also address in Gorilla to build the system. And this is answering the following question, right? How much does GPT-4 hallucinate? Now, normally if it was in person, I would have prompted you all for some answers. But I mean, look, I want to be very clear in the claims. Hallucination is an ill-defined metric for general domain. Right? It's very hard to say what's hallucinated versus what's inaccurate. But what I'm going to claim is that for APIs, there's a very clear metric on measuring hallucination. And to do this, we're going to use a very classical concept from the programming languages literature called abstract syntax tree subtree matching. So the goal here is the following. I need to measure hallucination, right? So how do I do that? Let me walk you through with an example. So here's one API call. It's a PyTorch Hub API call where I'm trying to call this particular model called PyTorch Vision, or that's the repository, excuse me. And the particular model I'm interested in is DenseNet 1-to-1. And of course, there's a pretrained equals true, which is an optional argument. So the first thing that we're going to go and do is build a subtree using these sort of APIs, right? Or this particular API call. And then I'm going to make a claim. I claim that given a snapshot in time, you know all the APIs the service provides. As time varies, the set of APIs the service provides may vary, but given a snapshot in time, the set of APIs that someone provides you is constant and fixed. So what I would have done is I would have built a syntax tree, abstract syntax tree of all the APIs that Torch provides. And then I ask a simple question. Is this API that the LLM generated a proper subset of my tree or not? And if it is a proper subset, then I claim it's not hallucinated. Keep in mind, I'm not commenting on accuracy. I'm only claiming if it's hallucinated or not. And by doing this, I can actually measure what's my extent of hallucination, right? So let's look at how well the model performs using these two metrics. So on the y-axis, I have accuracy, and on the x-axis, I have hallucination. And to repeat, one does not mean the other, right? So to give an example, suppose I want to send $100 to Shri. I can use a PayPal API, which would be the accurate way to do that. Or if I ask the LLM, hey, how do I send $100 to Shri? And the LLM says, use PyTorch API. Now you can't send money to each other using PyTorch. So it's not accurate, but it's not exactly hallucinated, right? Because PyTorch APIs do exist. They just don't do the task well. On the other hand, if the LLM said, hey, use the Shri API, then that API does not exist. So that's hallucination. So you see, if I were to send $100 to you, if the LLM says use PayPal API, it's accurate. If the LLM says use PyTorch API, it's not accurate, but it's also not hallucinated. That API exists. But if the LLM says use XYZ API, which is made up, then we call it hallucination, right? So you want your accuracy to be high and you want your hallucination to be low. So you roughly want to be in the top left corner. And what we show here is with zero shot, which means you just ask the prompt, there's no retriever. You can see that Gorilla performs quite well compared to even closed source and open source models. And of course, what if you use the best retriever, which is text.r002? Well, this was text.r002v2 with similarity search. And what if, God gave you a retriever, the Oracle retriever? And what we show is in all of these scenarios, Gorilla matches, if not, sometimes beats the performance of even closed source models. And you also see some interesting observations here, right? So for example, GPT 3.5 hallucinates less than GPT 4, which a lot of people have also been had similar experiences. So yeah, you could see a lot of interesting stuff with this sort of metric to measure hallucination and also a way to measure accuracy. Okay, I know this has been we have walked through a few different concepts now. So I want to pause and ask if there are any questions. And Shri, maybe you can put it in chat, or maybe you can, students can speak out. Either way works well for me, but I thought this might be a nice logical point to ask for questions. I can't hear you if you're speaking. I think both. I can
show?
hear you now. Yes, I can hear you now.
I wanted to understand the reason why llama is performing badly with more retriever provided. The hallucination in llama has increased as shown in the graph. Is there any particular
Any specific reason why llama performs worse compared to other models is the question.
Yeah, well, okay. So I think so there's two parts to it. Why does llama perform worse? Well, because these models probably already have some of these APIs in their training set. I don't know, right? I don't know how close those models trained, what they have. And so, by the way, I've presented this here so that it's easy to understand, but we also compare with MPT, which is a Mosaic, and the Falcon, which was two Apache open source models as well. I think there's another sub question is why does hallucination increase as we give retrieved documents, if I recall correctly? And this is a pretty interesting question, right? And the other dual of this question is why is it that even with an Oracle retriever, you still have hallucination even for something like GPT-4 and GPT-3.5? And our observation is that when you give a retriever, that does not mean that the model does not hallucinate, right? So one example is in the Helsinki NLP that I showed you, even if you give a retrieval, sometimes we observe that the model comes up with opus empty English to French. Now that API does not exist. It's opus empty EN to FR, right? So even though you give EN to FR in your prompt, it's quite likely that the model will hallucinate and come up with, it'll assume that there's a new API based on the API style. So yeah, there's a few different examples or like few different themes that repeat over and over again. And by the way, all of this data set that I've been showing you right now is all open sourced. So you could also go and poke it and play with it. Yeah.
Any other questions?
Hopefully that.
Did that answer your question? Okay, yep. Any other questions? So, Shishir, I had a question. So you mentioned like 20,000 APIs are kind of connected with Korea. So did you manually curate it, or was it based on usage and there was basically
Yeah.
retrieval of those APIs, or how did that whole 20,000 come about?
Yeah. So there's two parts to this question, right? One is how do we create it, and second is how did we pick which APIs? And so the short answer is when we started this project, we picked machine learning APIs, which is all the APIs in TensorFlow, Torch Hub, and Hugging Face. And the reason we did this is because, well, a few things, right? One is we're trying to write a paper for machine learning audience, but more interestingly, a lot of machine learning APIs look and feel very similar. Like between ResNet 50 and ResNet 101, they're very similar, except they might vary in performance and systems numbers like latency and peak memory consumption. So so this is a good check for the model on how well it can discern or distinguish between these two. Like making the model distinguish between a ResNet 50 and a ResNet 101 is much harder than making the model distinguish between a WhatsApp for business and say a Stripe API, right? Which are extremely different. So that's part one. And the part two is which APIs we selected is once we put these out, like we have a Discord, a pretty active Discord, where a lot of people were like, hey, Kubernetes is hard for me. Hey, hyperscalers are hard for me. So people start giving us a lot of feedback on which APIs that they want included. So that's when we start adding more APIs. And there's also, and so we also have an index where we you can search for it. And there's like a whole different set of APIs. So you could use this also as a way if you're trying to build a project as a quick source to check all the APIs and all the APIs that we support. And how we created these APIs as well, a lot of those are community contributed. So we have something called the API. So if you go to GitHub, there is something called the API Zoo. And the API Zoo has you can contribute your own set of APIs. So people do this. And this is actually not that hard. And the reason I want to highlight this is if you look at, there's been a lot of news recently of, oh, did any of these proprietary models use copyrighted data to train? Was a New York Times article, so on and so forth, right? That's because the incentives are not aligned. Whereas with APIs, the incentives are very well aligned. If I use Stripe API, Stripe makes money. If I use DoorDash API or Uber API, Uber and DoorDash make money. So the incentives are very well aligned that a lot of these API providers provide documentations to users that are very well curated. Like that's open API specs, Swagger files, examples, readmes. So it's, getting APIs in well-crafted form is pretty, I would say, is more well-incentivized technique and hence more mature than, say, other sources of information.
Actually, I had two follow-on questions. One, the API selection. So how do you rank these APIs if there are, payments, let's say there are two potential, a PayPal API versus a Stripe. How do you rank these APIs? Is it driven by, if you think about economics, if Stripe wants to, you do an auction and get the biggest, the highest paying API to be connected. That's one thought. But the other thought is also how do you take care of the lineage of the versions? You mentioned 1.1 versus 1.2 versus 1.3. Maybe I want to connect to an older API by default just because I've built all my systems relying on that particular version.
Yeah, a good question. So let me answer this two ways. One is what we do currently, and the second is what we think is the right way to do and is the future. So right now, the answer to your question is, what we do currently is what if people wants to send money and then there's Stripe and there's Adyen and both of those are valid APIs. In my mind, if you ask a question, any answer that satisfies the question is the right answer. Right? If you say, oh, I want to do X, like I want to do object detection, I can give you RESTnet, I can give you Swift, or I could give you MobileNet, right? There's different ways I can give you, and all of these are correct answers. But if you introduce constraints, if you say, I want to run this network on my machine, I want to run this machine learning model on my smartphone, then probably MobileNet is the only one that fits in RAM, right? So the answer to your question today is if the user asks a question, any answer that is the right answer, if the model gives, I would claim it is the right answer. And the model can stochastically pick from between the two. But if you add constraints, then the set of scopes of correct answers reduces, in which case you need to check did the LLM respect the constraints that you provided, it satisfy that or not. Okay. In the future, in those scenarios where, if someone asks a question and then two answers are the right answers, what I think is the right way to do is to have some sort of an, how iOS and Android have app stores. Can we have some sort of app stores that record certain metrics, right? Like, can I record latency? Can I record cost? Can I record reliability? So can I use some of these as ways, like, today if you go to an app store, you see reviews, which is usually a linear scale 0 to 5 stars or something. But can you have like some of these different metrics so people can use this, or the LLM can use this to then recommend the API to you, which is probably the least latency sensitive, the least in terms of latency penalty, or maybe the cheapest, so on and so forth. That's probably one direction.
I mean, I'm kind of thinking in the context of the decision criteria, right? So one is the technical aspects wherein you can optimize it to make a decision based on the technical criteria. But I'm also thinking like, how do you incorporate economic theory? Because obviously, if the incentives need to be aligned, the economics need to be aligned too. So, I mean, if someone has like a free API and it gives decent information, probably that's the goal, that's probably the right source. But there may be someone who wants to incentivize you as a service provider to be used compared to that other, even potentially better API.
Yeah, I think that's pretty exciting. I think the crux of your idea is you're anyway building this sort of like two-sided marketplace where you have the users requesting APIs and service providers giving you these APIs for the model to train. Can we also have a way where they could, choose their metric, cost in this case, and then bid on it? That's pretty exciting. Yeah, but I haven't seen much work in that direction, though that's a good area for research. Yeah.
Cool. Awesome. Okay, any more questions? Okay, so let's continue, Shishir. Thank you.
Yeah, okay, awesome. So moving on, so this project is actually quite it's already open source, right? So we are trying to like take this beyond a research artifact. So we have been on the top of Hacker News multiple times by now. There's a pretty active community of contributors and people who are using the project. We have been in popular press, both domestically and internationally as well. And what's more motivating for us is a lot of enterprises go and train their own gorilla using the concepts that we have. So VV8, which is a vector database company, trained it. And it's also been today, the CLI tool that I showed you, for example, is being used at multiple enterprises already. And so we have served hundreds of thousands of requests from a small hosted endpoint, though this is not the only way you can use it, right? Because our models are also open sourced on Hugging Face. So people can just download the models and use them. Okay, so this is the Gorilla project. And what I want to do next is talk to you about another project called RAFT. And so the Gorilla was more, think of it as, okay, you're trying to use this, you're trying to like build systems that are interacting with the world, and that's the use case, right? So we took the retrieval aware training idea and we extended that. We pioneered it and we made RAFT. And so RAFT is quite interesting in the sense it's actually quite relevant right off the bat to most people today. So what's RAFT? So RAFT stands for Retrieval Aware Fine-Tuning. And the goal of RAFT is, can we adapt language models to RAG, right? So RAG is Retrieval Augmented Generation. So let me walk you through some examples to motivate what we're doing and give you an analogy as to how this is relevant to how students take exams, right? So, okay, suppose I want to prompt the LLM, ask it a question, where is the capital of California? Now, I say questions like this is in domain. In the sense the LLM has been trained on this, and most likely this is not going to change much, right? So LLM is going to say, hey, it is Sacramento. Great. Now, suppose I were to ask an out-of-domain question, like, hey, please help me find who won the 2024 Super Bowl. In this case, the LLM is going to say, well, I only have knowledge until 2023, right? So I have no idea who won the 2024 Super Bowl. So to understand what's going on here, let's take an analogy of how students give exams, right? Suppose you have an exam. One way you can prepare for this exam is actually studying for the exam. So, and this is the classical closed book setting, right? You study at home, you go to your exam center, they give you questions, and then you give them answers. So that's the left-hand side, the closed book. Or you can do an open book setting where suppose you're facing an exam and the teacher tells you, well, you can get any book that you want. You can get all the textbooks in the world. Now go and give an exam. Now, this is slightly better, but I would argue it doesn't help much if you have no idea what you're doing, right? So, so all of you are in the IT space. If I take you to a legal school exam, an exam in the law school, and I give you all the textbooks with all the case studies, and if I give you a set of questions, you'll have no idea. You're going to spend all your time just indexing the textbook, right? Trying to figure out where what is. So RAFT is a solution to this particular problem, which is, can we lightly study for the exam? And by lightly study, I mean, can you prepare for the exam by, for example, indexing the different chapters of the textbook? So when you go to an open book exam and you're given a bunch of textbooks, you have read the textbook once so that you don't remember where you don't remember what things are, but you know exactly where they are. So if you were to give an exam, you know exactly what to look up and answer the question. So in terms of analogy, that's our goal with RAFT, right? LLMs are going to be used to answer questions out of domain. Can we teach the LLM to read the documents that's been given to it through RAG in a slightly better fashion? So that's the RAFT setting. So, in this case, if you were to ask the following question and your retrieval were to give you 3 documents, can the LLM now read the relevant document and then answer the question that, Kansas City Chiefs won the Super Bowl in 2024? So this is the setting. So to go back to the analogy, asking it without giving RAG is a closed book exam where you didn't study. And our goal is to teach the LLM for an open book setting where you actually do study for it to answer the question. So this is with respect to exams. Going back to LLM space, the question we want to answer is, how do you train a model? And by train here, I mean fine-tune an LLM for open book exam, right? So you know that you're going to use your LLMs in a RAG setting. How do we now optimize this model for this open book exam setting? And so if there's one key takeaway you want to take from the second part of the talk, is that RAFT is a training procedure for open book question answering. in other words, retrieval augmented generation, right? So if you're doing RAG, then you should be doing RAFT, basically. So what's RAFT? RAFT involves a few key steps, right? The first is when I'm trying to like prepare the training data set, not only am I going to give you the relevant document that has the answer to your question, but I'm also going to give you some distractor documents. Now, why is this critical? Because there's been a line of work like lost in the middle that show you that if you have too long of a context, then the LLM tends to forget things in between. There's also been a lot of significant work that has shown that if you give the LLM a lot of junk, then it's very easy to distract the LLM and the LLM starts hallucinating. So we want to account for this, right? So when you ask the question, the prompt here is who invented transformers, the LLM is given both the Oracle document, which is attention is all you need, and the distractor documents. And of course, you want to like shuffle this around, so on and so forth. So this is at train time. Now, there's a few other things that we do, right? So retrievals are never accurate. By accurate, I mean, if you look at recall at K, it's more often than not never at perfect recall, right? Even at K, K not equal to 1. So then we want to answer the question, well, what if the retrievers can be inaccurate? Then can the model actually ignore the distracted documents that's in the retrieved context and use some knowledge from its pre-training set or fine-tuning set to answer the user's question? So that's another key trick in the RAFT training pipeline. And so that's training at inference time. You ask the following question, your retriever on the left-hand side picks your top K documents, and then the LLM now looks at this document, figures out what's relevant, what's not relevant. So here it's going to discard the Llama 2 and the MPT7B document, well, discard implicitly, and then answer the question from references at the Mistral 7B document at test time, right? So this is a way to generate the self-instruct data set at train time. And this is a way to answer the questions at test time. So this is a train and test setting. Now, there's a few more things that we do interesting with RAFT. One is to craft your answers as chain of thought style, right? So we not only ask the LLM to answer the question, which in this case is sliding window attention, but we also ask the LLM to verbatim cite which particular tokens or which particular run of words in the document are actually useful in answering this question, right? So this is the RAFT training and inference pipeline. And you can see how this is quite relevant, right? So, most LLMs today are like trained general purpose, but suppose you want to use it in your medical domain, or you want to use it for industrial automation, or you want to use it in law, or you want to use it in just computer science even for development, how you can now fine tune the LLM for your proprietary internal company documents to do DocQA or your internal code base, so on and so forth. And this is actually quite relevant, right? Because, suppose I were to ask you the question, when was Michael Jordan born? Well, am I referring to Michael Jordan, the basketball player? Am I referring to Michael Jordan, the professor of computer science at Berkeley, or whom, right? So answering questions like this becomes super important if you can if you were to like interface some of your enterprise products, and then you have to do in-domain fine-tuning in this scenario, right? So this is the high-level idea of RAFT. And so RAFT we released recently. This was joint release with Microsoft and Meta. So you can actually use this. So you can use our repository to come up with a self-instruct training data set. So RAFT is a recipe to come up with the fine-tuning data set, right? You're still doing perplexity laws just on the answers and not on the questions. So RAFT is a way to come up with a self-instruct data set, and then we have an Azure service which you can use to deploy, fine-tune the model, and then deploy. And of course, you don't necessarily have to stick to Azure. You can also do this locally on your local machines, or pick your favorite LLM fine-tune and inference hosting service, and you can use RAFT in all of these places. Okay, I have a few topics I also want to touch upon, but any questions so far on RAFT?
It's gonna up with that. Any questions regarding the methodology? Any clarification questions, or you want Shishir to explain anything specific? So I actually had a question about the fine-tuning part, Shishir. So you had like, the open book learning paradigm.
Right.
How would you kind of, let's say, I mean, I'll just pick a random example. You are in a healthcare setting and you have a lot of healthcare related domain specific documents, and you're trying to, if you just use, GPT-4 or Llama or any other generic LLMs, probably they are not going to be appropriate in deciphering the medical terminology. And your goal is to, first of all, contextualize the LLM for the specific medical domain. I mean, it could be, uh, prescriptions, notes from doctors, reports from, radiologists, whatever, right? So what would be the workflow for someone who would be kind of curating, and in what particular methodology to first fine-tune the operationalization aspect, if you will, to fine-tune the LLM? That's first question. Let's say I pick up a Llama 7 billion parameter model, and I want to kind of keep it running on a private cloud and first fine tune it, and then potentially use it for, using RAG when have new notes, and I may have to do classification, personalized recommendations or summarization or whatever other, tasks I may want to do on this fine tune LLM, which I would potentially do benchmark on a regular GPT-4 kind of a setting, if you will.
Right. So let me maybe give an example. And let's take the medical domain example that you had, right? So the question here is, well, I have this domain, I have a set of documents. How do I take these documents, and like, what is the step-by-step to do this, right? Like, how do you operationalize it? So here's an example. And so this is not medical domain, but you can assume it's, for all intents and purposes, it's the same, right? So here you have a context. This is some document, right?
Mhm.
The first thing that you want to do is you take all of these documents and you ask a general purpose LLM, and this could be a Llama 70B, this could be GPT-4, etc. You ask it, hey, can you take this context, can you take this document and come up with a question and an answer that you think is going to help, that's potential of what a user might ask. So you have this document, and so there's ways to do that, right? First, you need to come up with like six question answer examples, and then we randomly select 3 of those. So it's 6P3, 6 choose 3. Of course, you can permute it, so that there's some stochasticity, and then you prompt an LLM with in-context examples, and the LLM comes up with the question and the answer. So this is a pretty standardized now self-insert generation process. So you take this context, and you ask the LLM, hey, can you come up with a question? So this would be the question, and this would be the answer, right? So here the question is, well, your Breuer family is part of a hotel company that has a head office in what city? And you have a bunch of documents. There's also distractor documents, about JW Marriott Hotel and so on and so forth. But you want the LLM to come up with the answer, while based on this document, and this is the part where I was telling you about, there's a begin quote and an end quote, right? So you want it to like faithfully also verbatim cite the document. It's going to say, the Oberoi family is part of a hotel company whose head office is in Delhi. So the answer is Delhi. So you basically took a document, and a document here would be a medical document, and a general purpose LLM came up with a question and an answer from this document. And keep in mind, this is a simpler problem than the one you're trying to train the LLM. Because here, think of it as, if I give you an answer and ask you to come up with a question, it's much easier than taking the question and coming up with an answer, especially if you already have it on the document. Right? So this is how you generate the self-insert data set. And once you generate this, you then take this data set, and then you go to an LLM, and then you're trying to now fine-tune the LLM, right? So you're trying to like maximize the probability of the answer conditioned on the question and the document. So you are trying to like, this is the question now, once you generate the data, and conditioning on this document and the question, you want the LLM to come up with the answer. And keep in mind, even over here, there are distracted documents, right? So it's basically, you're trying to like give the LLM the question plus the Oracle document and the distractor documents, and you want the LLM to come up with the answer for 80% of the data set. And for 20%, you don't use the right question. You just give it distractor documents and you still ask it to come up with the answer. So this is how you would come up with the self-instruct data set. And once you have this, you would go ahead and you would do supervised fine-tuning or instruction fine-tuning to train a Llama 7B or like a Llama 13B sort of model.
Cool. Now, how much of this is manual and
yeah. So the only thing manual is coming up with 6 question answer examples. So you see this? This is already one. So this is already one question answer example. You have to come up with 6. Well, we came up with 6. You could do 10 or whatever. So you have to come up with 6 of this. Everything else is automated.
Okay. So the automation, how do you introduce variety? I mean, like if you're thinking about, just
Exactly. So that's why we're using 6, right? You're trying to like do 6, choose 3. So every time you randomly pick 3, and then you change this enough that there's enough stochasticity in the process.
Okay. Okay. And how do you when I look at medical, probably 6 is not enough, or is there a
Oh, but this is mostly for style, right? Like, by the way, this is not 6 per document. Suppose you have 100,000 documents. You would pick random 6 documents, come up with question answer for those random 6 documents. And then you would use this to train the model, like examples of what style it needs to follow.
Okay. Okay.
So it's not, yeah. So it's like, based on the document, you'd get different. Like if you have 100,000 documents, you have 6 examples based on 6 documents, but then you randomly pick 3 in your examples. And for all 100,000 of those, you have unique question answer pairs given the context of the document.
Okay. Okay. And how do you test the quality of the outputs when you kind of use your LLMs?
Yeah, excellent question. So I don't have science, I only have art, right? In the sense, like some examples, like PubMed is medical domain documents. So here the answers are mostly yes or no. So if you have yes or no questions, it's very easy to come up with the answer. For everything else, it could be quite hard because how do you even know? Like, do you check for exact substring match? What if the output is more verbose than what you expect? Even measuring becomes, there's Ruchel and a bunch of other metrics that help you do that. But to improve it, this is the technique that we have, where you actually make the model quote pieces of the document that you think is necessary, and then do some chain of thought style prompting, or like you ask it to think step by step and come up with a chain of thought style answer. And this tends to work well. And so since we were trying to build a data set, we manually verified every single one. But if you're using it in production, you would like try to sample a few and check. But oftentimes, like these are quite robust to noise. So as long as it's not terribly off, the model should converge well.
And is there any kind of tracking wherein there is some kind of a human in the loop, wherein you basically get the human to provide an opine on the quality and then basically kind of use that as feedback? Is there a loop there, or
No, I mean, you could use that to modify some of the in-context examples are more probably prompted better, but I don't think much beyond that.
Okay. Okay. Cool.
Yeah. You should think of this as a pipeline that mostly works end-to-end. You might have to like poke in between to just do some sanity checks, but there's no critical human in the loop process other than the 6 example generation steps.
No, I'm just kind of thinking, how do you make, if we are going to be benchmarking RAG versus RAFT, right? And as the quality of the actual models themselves evolve, what is the role of fine tuning? And if fine tuning is actually is going to provide you some kind of step function which linearly will increase in terms of some performance metric based on whatever you're trying to do, how can you keep that process optimized, in the big picture when you are incorporating it as a process rather than constantly trying to like fine tune, okay, now I'm switching my model, now I need to redo my whole pipeline again, and whether this even makes sense, kind of a thing.
Yeah. I think I've answered your first part of your question. Maybe the second part, is still TBD, right? So, so this is where you're using GPT 3.5 and RAG. This is open source model. This is if you were to do RAG plus open source model, this is just fine-tuning. And this is, can you do fine-tuning plus, so fine-tuning at train time, RAG at test time versus doing RAFT. So you can see that there's performance benefits across medical domain. Hotpot is Wikipedia style, Hugging Face, Torchub, and TensorFlow, machine learning APIs from the Gorilla dataset. So across natural language, medical, and quote unquote APIs and coding, you can see there's like some trends, right? You can see how RAG is good, but at the same time, like fine-tuning and RAG can get mostly better, though sometimes not for Wikipedia. But like doing RAFT is consistently better because you're like, accounting for all the shortcomings in your retriever, shortcomings in your fine-tuning steps, so on and so forth.
Okay.
And okay,
sorry,
yeah.
Have you had success in any specific domains wherein people have taken this approach and say, oh, you know what, we have actually productionized this, or maybe even like we have qualified that this is actually a better approach in some kind of a practical setting? I don't know, banking, insurance, or healthcare, or whatever other domain. I mean, I presume a lot of people knock your doors trying to like see if they can use this approach for their use case.
Right. So this was released exactly 1 week ago. So
Right.
it's too early. The Gorilla has been released for a while, so we know a lot of people who are using it. So this we're talking to a lot of people, and most people who are trying to do RAG, especially for like proprietary internal documents, right? Like chatting with your set of enterprise data. Chatting with enterprise code seems to be popular, but yeah, I need at least a couple more weeks to give you concrete examples of how people are doing and what seems to work and best practices and stuff like that. Okay, so we are getting close to time. So in the interest, what I want to do is I want to also, we already seen this. I also want to talk about maybe 2 more tools that we have that some of you might find interesting to play around with. Uh, just briefly, right? So one of the things is open functions. And the goal with function calling, some of you might have heard of it as tool calling or function calling from OpenAI, is you're basically given a list of functions and the model has to return the right function with the arguments filled in, right? So one example for this is to say, well, the user asks what is 2 plus 3, and they give the LLM 2 functions, add and mult. And then the model is supposed to pick add and then return A equals 2, B equals 3. And parallel functions is where you can ask, hey, what is the weather in Berkeley and Boston? And you give it the weather function, it's supposed to return the weather function called twice, once with Berkeley and Boston as the arguments. And this is an example for addition, right? It calls addition twice with this. And some of you may be asking, hey, how is it different? Well, this is different because people are looking at this as, well, if I'm going to use my LLM in agentic scenarios and I want it to like follow proper schema. So you want it to be like well structured. There has to be no syntax error and stuff like that. Then function calling tends to work well in those scenarios. And so we released something called the Open Functions V2, which is the state of the art for an open source state-of-the-art model to call functions. And more critically, a lot of closed source models today support either JSON or XML schema. And we were the first to support Java, JavaScript, and HTML as you can have like float data types. A equals 2 can be of type integer and not just of type quote unquote number, right? So that's the idea. But what I thought would be more interesting for some of you is we also have something called the Berkeley function calling leaderboard. So the goal here is, can we benchmark a lot of these models and how they perform in calling these functions, right? So one AST means we're going to use the abstract syntax tree. So it's an offline metric to evaluate these models. And then the exec means execute it. Can we actually execute it and then verify that this works end to end? And relevance is quite important, actually. If you ask the model, hey, what's the weather in Berkeley, and you give it an add API, the model has to come back and say, I really can't answer your question because you haven't given me the relevant API. So, and it's very hard to get models to say, I don't know. So with relevance, our goal is to also flag this. And we're having, soon we're going to also add like stuff like latency, like, how long does GPT-4 take on an average for your set of calls versus how long does Claude take, and the cost and metrics like that. So, and there's, you can, of course, double click and say, I want to think of simple functions, parallel functions, how do they perform, so on and so forth. And if you're trying to decide which models to pick, like if you're having projects in mind and you want to understand how different models behave, then there's this like wagon wheel style where you can try it out, on different metrics, whichever you choose. And you could also like actually, so here's an example of the prompt, and you're giving it this function in the JSON schema, and then you want the model to output the response and the model response as well. So these are, I thought I would share this because if you're considering using function calling, you don't have to use the Gorilla as such, but just to measure how different models perform and so on and so forth. And this is an open source effort, and we have a lot of and even the model providers looking at this, trying to understand what's going on. So if you're interested in extending this or working on this or adding more models to this, I'd be happy to collaborate as well. So, and you could just play around with this. You don't need fancy GPUs or laptops to do this. So anyways, yeah, I think that's all I had. Let me conclude by we built the Gorilla LLM because we had this vision of, can you actually like flip the human from the center to the human on the other side and have your LLM talk to different APIs, because we thought humans are good at just to evaluate the response rather than evaluating the process. And the retrieval aware training and using AST tree to measure hallucination was some of the key ideas, which we introduced in the Gorilla paper, but you can actually use it even outside of Gorilla. If you're trying to do something and you want to measure hallucination, AST is a good way to go if it can represent it as a tree, needless to say, right? And yeah, we took the retrieval aware training to build a better RAG system called RAFT. So if you're trying to do document QA, if you want to like optimize your model for RAG, you should do RAFT. And like I said, all the code is open source, and it's pretty ready for enterprise adoption, right? Because we also have examples on how you can deploy this on Azure and use this as a service. With open functions, our goal was to like come up with a function calling model. And once you build this model with function calling leaderboard, our goal is to try and understand, hey, how do these models perform? Can we get more insights into what's going on? Are there like generic cases where these models fail? Are there cases where these models perform well? What's easy, what's hard, to inform how people do research on the next steps of models and APIs and tool calls and roughly this direction. With that, back to you, Shri.
Shishir, thank you so much for the wonderful presentation. So Shishir is available online, so he's on LinkedIn. So you should be able to connect with him in case you have any questions. And also I can share his contact information if you guys want to pick up, any one of these projects for your final projects and want to either extend or try out a different use case or maybe work on a different data set and maybe kind of, give it back to the community. There is a Discord channel, as Shishir was mentioning. You can join that and maybe just engage in the discussion and see what else is happening there, and maybe even contribute to some of these. Many of these are open source projects, so it'll be a nice thing to kind of engage in projects which are already being used, and also trying to see if you can learn from the community. Okay, cool. Thank you so much, Shishir. Again, if you're in the Boston area, your next cup of coffee in Boston is on me. Okay.
Appreciate it. Yeah. And thank you all for listening.
Yeah, so please do visit Northeastern the next time you're here, and looking forward to collaborate in some way in the future.
Thank you, Shri. This was fun. All right, see you.
Cool.